All right, I just wanted to walk you all through the discussion this week for Module 2 and talk about how to do Option 1. Since I think a few people were a little confused about how to look at the underlying original population and then transferring that to looking at several sample means. This points to the central limit theorem, and we'll talk about that in a minute. So let's start. This right here is from our weather data set. It's DX32. Remember, that's the number of days in a month that are less than 32 degrees. So you see here it's kind of cyclical, where in the summer months, spring and fall, you see no days that are super duper cold. And then your winter months, you see increasing number of days that are really cold. So first, the discussion this week wanted you to take a sample of 30 and look at the histogram of that. So let's, just for our sake, let's take a quick look at the full data set to see what we're looking at for the full data set. So I just went to, let's do that again, graph, histogram. I selected the column. I'm not even going to worry about it. You can select to have your mean and median markers on there. We can check that, but we don't need to. I just want to get an idea of the overall shape. So as we see here, it's very right skewed. We have a lot of days that are not super cold, and it tapers off here where the tail is to the right. That's right skewed. And that's what you'd think intuitively, right? You expect more months to have 0 days that are super cold than you would more months here on this tail. It's very uncommon, as you can see, to have over 25 days in a month that are below 32 degrees. That would be an extreme cold, probably record-setting cold. So again, most of your months are going to be here at 0, and that makes sense with what we would expect. So now that we know what our full data set looks like, let's go ahead and take a look at let's look at a sample. So we're going to go to Data, Sample. We're going to select the column we're sampling from. Then we're going to come down here and select the sample size. The prompt this week said to look at a sample of size 30. And right now we're just going to look at one sample. Click Compute. See how it gives us a little thing. Oh, this new column was created. So now we have our full histogram and our sample. So let's go to Graph, Histogram, select our new sample, and we can go ahead and check these if you want to see where the mean and median are again. We're going to click Compute. Well, look at that. They're very similarly shaped, and that's what you would expect. If you're taking a sample from an overall population, you're not changing it, you're not looking at the mean, you're just looking at that same variable, DX32, you would expect a similar shape if the sample is random. All right, so that gets at that. Now, the next thing that the prompt told us to do was to imagine. You don't have to do the actual sampling, but it says imagine if you were to take 99 more samples for a total of 100 samples, each of size 30, what would the shape of that histogram be? Now, that points to the central limit theorem. The central limit theorem tells us that regardless of the underlying population, if we were to sample, the mean of the distribution of that mean, that sample mean, becomes approximately normal as n increases. That means the more observations you add, the more samples you add, the more normal the population is going to look of the sample mean. We are no longer looking at DX32. Now we're looking at the mean of 30 observations of DX32, the mean. And that's why it's important to understand the difference there. That's what that central limit theorem tells us. Now, we can know that just based on what it's saying, but let's say we want to get a little look at that. Let's go ahead and go to Data, Sample. We're going to select from our original DX32 variable that we copied in. We're going to make our sample size 30. And now instead of taking one sample, we're going to take 99 more. We already have one right here. We're going to take 99 more samples. Click Compute. See, it gives you a little thing. It says, oh, look at all these that we added to the table. We added all these new columns for all of our new samples. See right here. You can see them all if you keep scrolling over. So now let's go all the way here to the end. Now what we're going to do, we need to take the mean of those. Again, we don't want to just look at all these 30 observations, 99 samples. We now want to have 100 sample means, one for each of these columns. So we're going to go to Stat. I'm going to go to Summary Stats, click Columns. Now we're going to select all, but I'm going to deselect that original variable because that's our full data set. We just want the 100 samples here. All right. We only want the mean. We don't care about the other summary stats. And we're going to store that data in a table. And you'll see what that looks like in just a minute. So make sure you check that. Click compute. And it gives us a little thing that it created a new table. We're going to scroll over. Look at that. It created this new column for us called the mean. And if we scroll all the way down, we'll see that it's all 100 sample means from those 100 samples that we just took. So now that we have a variable with our column here, we're going to go to graph, histogram, and we're going to scroll all the way down to that mean column. We're going to select that column, and we can even check our little markers right here for the mean and median. We're going to click compute. Well, look at that. This was our sample. This was our full data set. This is our new histogram based on those sample means. So again, instead of looking at the original underlying population, now we're looking at the mean of those 100 samples. And as you see here, it is much more bell-shaped. Our mean and median are very close together. Here they were separate, right? Which tells us that the data was skewed. Here they're very close. This data, we would say, is approximately normal, and that confirms what we learned from the central limit theorem. So that's how you could walk through how to do this. If you weren't sure how to do that in StatCrunch, you did not have to go through all those steps as it said in the prompt, but I just wanted to show you guys to illustrate that central limit theorem that we learned last week. If you have any questions about this, let me know.